In this class, we are going to discuss about phasor diagram of transformer. First, we will see about transformer on no load. See the diagram, it shows transformer on no load and phasor diagram of a transformer on no load. V1 is the supply voltage, I0 is the open circuit current. Since the secondary is open circuited and the primary coil is E1, primary coil induced voltage is E1, secondary coil induced voltage is E2, and phi is the linking flux between primary coil and secondary coil. See the phasor diagram in which the value of phi is taken as reference. The V1 is perpendicular to the flux phi. The V1 is perpendicular to the flux phi, that is with 90 degrees. Since the Im is phi is in phase with the Im is the magnetizing current, IC is the resistive current. Im is the inductive current, therefore it is 90 degree lagging with the V1. So the value of current flowing through the reactance is Im, the value of current flowing through the resistance is IC or I mu. The value of current flowing through the resistance is in phase with the V1. Therefore IC and V1 are in phase. IC and V1 are in the same line, that is in the phase. And the I0 is the open circuit current. It is having phase lag of pi naught degree. It is having phase lag of pi naught degree. Okay. IC is the resistive current. Im is the reactive current. The resultant current is called as no load current. It is having phase lag of pi naught degree. V1 is in phase with the IC. Phi is in phase with reactance, that is Im. Then the E1 and E2, the induced voltage E1 and E2 are in opposite to the V1 or in opposite to the V1. According to Faraday's law of electromagnetic induction, the induced EMF is opposite to the applied voltage. According to Lenz's law, it is opposite to the applied voltage. So V1 is opposite to the E1 and E2. So E1 is the primary coil induced voltage and E2 is the secondary coil induced voltage. So it is a phasor diagram of transformer on no load. Let's discuss about transformer on load. See the diagram, it shows the transformer, ideal transformer and the practical transformer. The practical transformer has main flux and leakage flux, but the ideal transformer has only main flux. See the phasor diagram of transformer with UPF, that is unity power factor load. So in which the flux phi is taken as the reference. Flux phi is taken as the reference. First we have to draw the value of input current I0, that is the resultant value of the no load current I0 and the primary coil induced current due to secondary coil, secondary winding flux, that is I2 dash. So the resultant value of I0 and I2 dash is the I1. I2 dash is in opposite with the I2. I2 dash is in opposite with the I2. So the resultant value of I0 and I2 dash is the primary input current I1. Then we have to go for the induced voltage E1 and E2. E1 and E2 are in 90 degree with the 90 degree phase lag with the flux phi. 90 degree phase lag with the flux phi. So in which we have to draw the value of E1 and E2 in same phase. In which we have to draw the value of E1 and E2 in phase. We are taking the step up transformer, so the value of E2 is more than the value of E1. Okay. So next we have to draw the value of minus E1, that is above the reference axis. E1 and E2 are opposite to the applied voltage, so therefore it is below the reference axis. Now we have to draw the value of minus E1, it is above the reference axis. Then there will be two components current, one is the resistive component, another one is inductive component. Now we are going to draw the voltage drop across resistance and inductance. The voltage drop across the resistance is noted by I1R1. It is in phase with the I1. So the line is parallel with the current I1. So with the edge of E1, we have to draw the line I1R1 drop. Then we have to draw the I1X1 drop, that is inductive drop, that is 90 degree with the I1R1 drop. The resultant value is called as I1Z1. The resultant value of I1R1 and I1X1, the vector addition of I1R1 and I1X1 is called as I1Z1. The total value of minus E1 and I1Z1 is the V1. That V1 is having phase angle of pi 1 with I1. Now take the below reference axis. We have to draw the value of V2 with respect to I2. Here we are taking the UPF load. Therefore, the I2R2 component is in phase with the current I2. I2R2 current is in phase with the current I2. Then with the angle of 90 degree, we have to draw the inductive drop I2X2. The total drop I2R2 plus I2X2 is the I2Z2. The I2Z2 plus E2 that gives the V2. Now we can represent the V2. So it is the phasor diagram of transformer with UPF load. See the phasor diagram of transformer with lagging power factor load. Here also the same things, the pi is taken as reference. First we have to draw the current, primary input current I1, that is the resultant component current of I0 and I2 dash. I2 dash is opposite to the I2. Then we have to draw the E1 and E2. E1 and E2 are having 90 degree phase lag with the flux phi. The E1, E2 are the induced voltage in secondary winding and primary winding. So the E1, E2 are represented below the reference axis with 90 degree phase lag with phi, that is the flux phi. Then we have to draw the minus E1, that is above the reference axis. Then we have to draw the drop I1 R1. The drop I1 R1. Then that is I1 R1 drop is having parallel with I1, is in parallel with I1 current. Then with 90 degree we have to draw the reactance drop I1 X1. The resultant value of I1 R1 and I1 X1 is I1 Z1. The resultant value of I1 R1 and I1 X1 is I1 Z1. The total value of minus E1 and I1 Z1 is V1. So now take the below reference axis. Here lagging power factor. Here we are going to draw the diagram, phasor diagram with lagging power factor load. So therefore now we are going to draw the value of E2 and V2. So first we take the value of E2. We have to draw the line for the I2 R2. We have to draw the line for the I2 R2, that is in parallel with the current I2, and with 90 degree we have to draw I2 X2. I2 R2 and I2 X2 resultant value is called as I2 Z2. E2 plus I2 Z2 is called as V2. That V2 is having phase lag of phi 2 with I2. Okay. So it is the phasor diagram of transformer with lagging power factor load. Next, phasor diagram of transformer with leading power factor load. The same thing, phi is taken as reference. First we have to draw the value of I0, I2 dash. I2 dash is opposite to I2. The certain value of I0 and I2 dash is called as I1. Then we have to draw E1 and E2 opposite to the applied voltage. Therefore, the phi is 90 degree with E1 and E2. E1 and E2 are in same phase. Now we are taking step up transformer. Therefore, E2 is having more voltage than E1. Then minus E1 is drawn above the reference axis. Then I1 R1 drop is represented with 90 degree of angle. I1 X1 drop is represented. The total resultant value of I1 R1 and I1 X1 is the total value of I1 Z1 drop. The minus E1 plus I1 Z1 is called as V1. It is having pi 1 angle with I1. Then we have to draw the value of V2. First take the value of I2, then draw the drop I2 R2. It is in parallel with the I2. Then draw the diagram for I2 Z2, that is 90 degree with I2 R2 drop. E2 plus I2 R2, that is certain value of I2 R2 and I2 X2 is I2 Z2. That I2 Z2 plus E2 is equal to V2, that is having phase lead of phi 2 degree with angle V2.